Good morning. Dwellings account for 60% of EU building energy use, 40 to 60% of which is energy used for heating, with 80% of the existing building stock proven to exist in 2050. With the Climate Change Act, low carbon retrofitting of this stock becomes a necessity for the UK, as it sets targets of 80% reduction in net carbon account emissions by 2050 and 34% by 2020, with a baseline of 1990. Aim of this study was to address the topic of sustainable refurbishment of the existing building stock by tackling the issues of cost effectiveness and embodied and operational energy throughout the life cycle of a residential building. This was researched by the comparison of a case study refurbishment complying with Part L1B and hypothetical refurbishment complying with passive house standards under the prism of cost per ton carbon saved. Achieving the passive house standard in refurbishments of existing buildings is not always a realistic goal. For such buildings, the Passive House Institute has developed EnerFit for certified energy retrofits with passive house components. This requires either a maximum heating demand of 25 kWh per square meter per year, or alternatively the consistent use of passive house components. The case study house is a Victorian semi-detached end-terrace house built before 1919. It is formed by two volumes, a 3-story one in the front facing northwest and a 2-story extension in the rear, and is currently used by its two owners. The total usable floor area is approximately 167 square meters. The ground floor consists of the hall, two living room areas connected with each other, and the kitchen in the rear extension. The staircase in the hall leads to the first floor's hall, which distributes to a front bedroom used as an office, a rear bedroom and office, and the bathroom and the utility space. The staircase continues to the attic floor, consisting of a guest room and a recess. This table summarizes the retrofit measures applied on each of the building's elements. I will leave you some minutes to look at them. So, among several measures, here we can see that the floor was insulated with mineral wool, the roof with rock wool and wood fiber boards, the walls with wood fiber boards, and skylights were introduced in the attic. This table summarizes the U values of the building's elements of the three cases in comparison. The pre-refurbishment and the current state were calculated based on the owner's descriptions and physical survey, whereas the EnerFit's based on the Passive House Institute directives. One of the most important questions in the process of achieving 80% reduction of CO2 is economic feasibility. In this study, a life cycle costing technique has been used for comparative cost assessments initially over a 30-year lifespan, taking into account the present value of initial capital costs, future operational costs and savings from the two different retrofit approaches. The operational energy use was compared between the pre-refurbishment condition, the current, and the retrofitted according to EnerFit standard. Energy consumption for heating was calculated using a multi-zone thermal model. The current house performed significantly better than prior refurbishment, with a 47% reduction in the total energy consumption and 70% in heating load, while the EnerFit house would perform even better with 61% and 85% reduction respectively. By comparison, the average heating consumption for the existing UK building stock is 180 kWh per square meter per year, 100 when renovated, and 50 to 60 for new build, which indicates that the current house performs significantly well. The EnerFit house performs even better, as expected, with a heating demand below 25 kWh per square meter per year. As far as costs are concerned, the passive house retrofit costs account for 130% more than the current one. In both cases, the most expensive intervention is the replacement of windows. Interestingly, the current roof refurbishment cost is 2.7 times higher than the EnerFit, which is attributed to the big price difference between wood fiber and mineral wool. The EnerFit refurbishment's embodied energy is extremely higher, 2.4 times more, with walls showing the greatest difference. This is mainly attributed to the use of XPS instead of wood fiber board insulation and the increased thickness needed to achieve the lower U values for the thermal elements. In addition, the triple glazed units and the insulated wooden frames and wooden door with polyurethane foam add 13% more to the embodied energy. Embodied carbon shows a huge difference as well between the current refurbishment and the EnerFit, in the range of 357%. This is due to the use of different insulation materials and thicknesses and concrete products for the floor insulation. The savings arising from the EnerFit refurbishment are constantly higher, although due to the high amount of embodied energy associated with it, the lifetime carbon saved is higher in the case of the current refurbishment. The EnerFit retrofit CTS appears 1.3 times higher than the current refurbishment, indicating that the extra initial cost and embodied energy involved is not offset by the higher savings during the operational phase of the building. In addition, the carbon savings for the EnerFit are quite delayed compared to the current retrofit, where savings begin just before the second year, resulting always in higher CTS. In addition, after the 13th year, the carbon savings from EnerFit outreach the current refurbishment. In both cases, the capital costs are not expected to be retained after the end of life of the project, which was assumed as 30 years, rendering both interventions not cost-effective. With regards to carbon and energy, the current refurbishment shows, as expected, shorter payback periods. The cash flow of a project associated with future expenditures and incomes is greatly influenced by time preference, which derives from the natural desire to enjoy benefits as soon as possible and to defer payments as long as possible. Therefore, the indicator net present value was used, which is defined as the sum of the present values of the individual cash flows of the same entity. The results of NPV for the two alternatives show that none of the two would give payback in a reasonable amount of time if discounting is taken into account and steady gas prices are assumed, with EnerFit having a higher deficit. In the model developed in this study, many assumptions were made, and the sensitivity analysis addressed the most important of them. With regards to fuel prices, the model used steady ones, which is highly unlikely to happen in real life. Energy prices show in general upward trends. Therefore, only with rising fuel prices, the initial investments would be repaid before the project's end of life, with EnerFit demanding in all cases longer payback periods. Its NPV is exceeding the NPV of the current refurbishment after the 33rd year. As far as CTS is concerned, when discounting and rising fuel prices are applied to the calculations, both cases show negative CTS values, indicating profitable investments. Yet again, the current refurbishment shows a higher benefit, which stays above the EnerFit one for 50 years. On the other hand, when steady prices and discounting are assumed, only the current refurbishment shows negative CTS in 50 years. In order to test the validity of the results in case of higher temperatures in the future, a new model was developed. As expected, the total energy consumption was reduced in all cases, with heating loads falling and electricity loads increasing due to additional cooling needed. The overall energy savings are minimized in both cases, especially in the current refurbishment, and consequently CTS and payback times increase. The current retrofit CTS has increased by 50% and the EnerFit by 47%, while carbon and energy payback times all rose in the range of 20%, rendering both interventions less sustainable. Therefore, it is evident that climate change will influence the benefits of retrofit measures as heating loads and thus operational energy savings will decrease, a conclusion applicable in the case of retrofit in warmer climates as well. One of the most substantial assumptions taken during the calculation was the project's lifetime of 30 years. As expected, the CTS for a lifespan smaller than the assumed one leads to rocketing of the CTS for both retrofit cases, as the operational energy savings are not enough to offset the initial investments. It becomes clear that for up to 24 years of lifetime, the Enerfit CTS is lower than the current one, while from the point they equalize until 90 years lifetime, it never exceeds it. Interestingly, the current refurbishment starts to generate profit from the 43rd year and the Enerfit from the 47th. The NPV shows different results over different lifetimes. The Enerfit option becomes more viable than the current one after the 29th year, with the difference increasing logarithmically within time, generating very high benefits compared to the initial investment. In the previous section, the effect on various lifespans on the CTS of the two retrofits was addressed, assuming that no additional replacements are needed, which could be considered utopian for a 90 years lifespan. Therefore, 5 replacement cycles were incorporated in the CTS analysis. When these replacements are included, no benefit arises within 90 years. And quite interestingly, the carbon saved in Enerfit managed to outreach the current after the 13th year, even though it is more decreased by replacement cycles. However, the Enerfit CTS remains constantly above the current one, leading yet again to the conclusion that it is less sustainable. All in all, the initial hypothesis that Enerfit is based on stricter U values and therefore higher insulation levels, it would be the optimal alternative by achieving higher operational energy savings, was proven wrong. The Enerfit's price to be paid in order to achieve those higher energy savings in terms of initial cost, embodied energy and embodied CO2 renders it a less appealing model than the applied one. The lifetime is a very significant factor to be taken into account, as investments with higher capital costs give higher benefit in the long term. Thus, only when a building is structurally intact and expected to exist for a long time, it is worth to invest in an extensive retrofit. Thank you.
Ευχαριστούμε για την παρουσίαση. Αν δεν σας πειράζει, θα ξεκινήσω εγώ με κάποιες ερωτήσεις. Το Enerfit, μας κάνετε μια εισαγωγή. Δεν ξέρω κατά πόσο ακουγόσαστε, ναι.
Το Enerfit είναι ένα στάνταρ που έχει αναπτύξει το Passive House Institute, επειδή τα στάνταρ που επέβαλε το Passive House ήταν πολύ αυστηρά για ενεργειακές αναβαθμίσεις. Οπότε αναπτύξαμε κάποια στάδια που είναι λιγότερο αυστηρά για να μπορούν να παίρνουν την πιστοποίηση ήδη υπάρχοντα κτίρια τα οποία μπαίνουν στη διαδικασία της ενεργειακής αναβάθμισης. Αυτό σημαίνει ότι ενώ το specific heat demand για ένα passive house είναι κάτω από 15 kWh ένα τετραγωνικό ανά έτος, για μια ενεργειακή αναβάθμιση είναι 25. Η πρωτογενής κατανάλωση ενέργειας είναι 120 και για τα δύο, αυτό είναι το ίδιο. Και το air tightness είναι πολύ σημαντικό, γιατί είναι πολύ δύσκολο να πετύχεις την στεγανότητα στο air tightness ενός ήδη υπάρχοντος κτίριου, όπως μπορείς να κάνεις ένα καινούριο. Οπότε αυτό είναι λιγότερο αυστηρά τα στάδια. Και πρέπει να χρησιμοποιούν συγκεκριμένες κατασκευές τις οποίες προτείνει το Passive House Institute.
Από ό,τι κατάλαβα λοιπόν μέσα από τη μελέτη σας ουσιαστικά βγαίνει ότι το Enerfit σε σχέση με τα υπόλοιπα δεν προσφέρει κάτι περισσότερο, άκουσα για χρόνους
πρέπει να είναι πολύ μεγάλη, ναι.
50 χρόνων και τα λοιπά. Πρέπει
να είναι πολύ μεγάλη η ζωή του κτηρίου για να μπορεί να κάνει απόσβεση.
Τα κόστη της ενέργειας τα οποία χρησιμοποίησατε όμως θα θέλαμε να ξέρουμε. Γιατί στην Ελλάδα από προσωπική εμπειρία οι αποσβέσεις γίνονται πάρα πολύ γρήγορα. Τουλάχιστον στα δικά μας κτίρια.
Είναι πολύ χαμηλό το κόστος, γι' αυτό η τιμή της κιλοβατόρας γαζιού στην Αγγλία είναι 0,04 λίρες. 0,04. Και του ηλεκτρισμού 0,14. Αυτό είναι με τη μέση του 2010.
Άρα δεν είναι φθηνότερος ο ηλεκτρισμός.
Ναι, αυτό είναι με τη μέση του 2010.
Ναι, και δεν έχουν ψήξει. Και γι' αυτό και είπατε ότι στην περίπτωση του global warming είναι πιο ευνοημένοι. Εμείς είμαστε οι χαμένοι. Να κάνω και μια τελευταία ερώτηση και μετά το δίνω στο κοινό για το life cycle cost analysis. Χρησιμοποιήσετε κάποιο software, κάποια
όχι, έγινε με το Excel.
Μάλιστα. Υπάρχει κάποια ερώτηση?
Υπάρχει κάποιο όριο στο οποίο μπορεί να γίνει αποδεκτό, δηλαδή είδα κάπου ότι λέτε ότι κάτω από 25 χρόνια δεν γίνεται αποδεκτό. Ή δεν υπάρχει αυτό το payback period.
Ναι, όλα εδώ.
Κάποια στιγμή είδα 25 χρόνια.
30 χρόνια.
Κάτω από 30 χρόνια δηλαδή κάποια ανακατασκευή κρίνεται ότι συμφέρει. Γιατί στην Ελλάδα να πάει πάνω από το κάτω δεν έχει κανένα. Γι' αυτό το λέω.
30 χρόνια θεωρήθηκε το χρόνο ζωής του κτίριου, επειδή ήταν το 1919, δηλαδή, και αυτό έγινε το 2013, οπότε βάλαμε ότι μπορεί να στέκεται ακόμα 30 χρόνια. Αυτό είναι μια υπόθεση που κάναμε, την οποία την τεστάραμε με sensitivity analysis μέχρι 90 χρόνια ακόμα ζωής.
Υπάρχει κάποια άλλη ερώτηση? Να ρωτήσω μια στιγμή πριν τελειώσουμε ακόμα κάτι. Υπάρχουν αρκετά κτίρια. Άρα δεν υπάρχουν, αυτό που έλεγε ο κ. λοιπόν πριν, άρα δεν υπάρχουν κάποια μέθοδος χρηματοδότησης για αυτού του είδους τις επεμβάσεις στα κτίρια στην Αγγλία. Δεν υπάρχει κάποιο support πάνω σε αυτό.
Υπάρχει, λέγεται Climate Change Act.
Όπου λειτουργεί με τον τρόπο όπως το δικό μας.
Αυτό δεν το ξέρω. Δεν ξέρω ακριβώς τα διαδικαστικά. Αλλά υπάρχουν σίγουρα κυβερνητικά προγράμματα τα οποία στηρίζουν χρηματοδότηση. Ναι. Ας πούμε αυτό έγινε με do it yourself, δηλαδή που το ξεκίνησε η ιδιοκτήτρια και το έκανε μόνο με την ίδια χρηματοδότηση.
Πάνω σε αυτό να ρωτήσω μήπως υπάρχουν ΕΣΚΟ οι οποίες συμμετέχουν και χρηματοδοτούν στον οικιακό τομέα, ΕΣΚΟ Energy Saving Companies, εταιρείες ενεργειακών υπηρεσιών, όπως τις λέμε στην Ελλάδα, που να χρηματοδοτούν και να πληρώνονται με συμβόλαια ενεργειακής.
Με απόδοση, αλλά ουσιαστικά μιλάμε για 30 χρόνια και έχουμε άλλο δύσκολο.
Από όσο γνωρίζω, η ΕΣΚΟ ασχολείται κυρίως με δημόσια κτίρια ή κτίρια γραφείων. Δεν δραστηριοποιούνται στον οικιακό τομέα. Από όσο γνωρίζω.
Ευχαριστούμε πάρα πολύ για την παρουσίαση.